Next, we want to see the geometric sequence. The geometric sequence, instead of the arithmetic one that is adding or subtracting, is to multiply or divide a number. Now, we tend to use decimals or fractions, so instead of dividing by 2, we might say times 1/2, or we might say times 0.5. If we're relying on a calculator, we're going to see the decimal a lot more when we're dividing. Multiplying by a decimal less than 1 is like dividing. But let's talk about the geometric sequence. If we want to find the geometric sequence of any number, g to n, we start with our first number, just like the arithmetic formula. A to the 1 represents our first number in a pattern. Then instead of adding, we're doing geometric, we're going to multiply. The common number we keep multiplying or dividing by we put here, but we call it r, common ratio, to the power of n minus 1. So we're using an exponent. And we're using an exponential graph, going up or going down. So how will we use this? Let's start with the pattern. If we're trying to decide if it's geometric or arithmetic, we might first subtract. 6 minus 3 is 3. 12 minus 6 is 6. And so we see right away it's not arithmetic. You're not adding the same amount or subtracting the same amount. So then the clue is going to help you to decide if it's geometric. Now we can divide. We're going to take the second one and divide it by the first one. Just like arithmetic, we work backwards. This one divided by this one. 6 divided by 3 is 2 times 2. 12 divided by 6 is times 2. And 24 divided by 12 is times 2. So we can see we're multiplying by 2 to get to the next term. This is the common ratio, or r. So now we can use this to build a formula, and we can find any term we want. Start with our first number, which is 3. This is a to the 1, our first number. Our common difference, or ratio, is 2. So our formula is our first number times the common number we're multiplying, 2, to the power of n minus 1. And that is our formula. We can now find any term that we want. So let's say I want to find the 10th term. G to the 10 will be 3 times 2 to the power of 10 minus 1, or 9. Because we're multiplying the first term and then 9 times more to make 10. Let's see what that is. Punch it in. So 2 to the 9 is 512 times 3. 3 times 512. So that's 1536. So how will we enter the exponent in our calculator? Let's talk about that in the next one. If we're using the same calculators at our school, we have Casio's. If I wanted to enter I'm going to multiply 3 and the times button and the 2 into the power of button. It looks like this. For Casio's, it's by your on the top right, by the clear button, I think. But our exponent. So this means 3 times 2 to the power of 9. That's our exponent button. Let's try another sequence. So from here to here is 4,000, but here to here, if we subtract this, it's negative 2,000, negative 4,000. So we know it's not arithmetic. So let's divide. 4,000 divided by 8,000 gives us 0.5, or we're dividing by 2. That's what 0.5 is. It's dividing by 2. 2,000 divided by 4,000 is also 0.5, and 1,000 divided by 2,000 is half, or 0.5. So our common ratio is 0.5. If I want to find any number, g to the n, I'm going to multiply my first number, 8,000, times 0.5 and minus 1. So let's try that. Let's find the 10th term. G to the 10 is 8,000 times 0.5 and minus 1, which is 9. So let's enter that. 8,000 times 0.5 to the power of button 9. And we get 15.625. If we round it to the 100th place, we would get 15.63. So geometric and arithmetic sequences are important formulas that we'll be using in this chapter.